John Michael A. Reyes, and I'm currently a second year BSIT student at Batangas State University, and now are in chapter 6, and we're going to answer all the activities here at chapter 6, and let's try to answer it. Wish me luck. And IP characteristic does not guarantee the packet will be delivered fully without errors. As you can see, this should be in the best effort because of the word guarantee. It is somewhat the conclusion or sa context clue that you can have if the answer is best effort. Let's try. Will send packet even the destination host is not available. It is somewhat connectionless. Then packet delivery is not guaranteed. As I've said earlier, guaranteed is the one of the best effort. Then and will adjust the size of the packet sent depending on what type of network access will be used. I think it would be in the media independent because it adjusts. That's why it can be independent. No contact is made with the destination host before sending a packet. As you can see, it is already in a connectionless because of the no contact is made. That's why we should always analyze. Then fiber optic cabling, satellites, and wireless can also be used to route the same packet, and that would go in the media independent. As you can see, I've correctly answered and matched the IP characteristic to their delivery methods. So let's proceed to then this is the second activity, the activity part 1, IPv4 header fields. Then let's try to identify what the function in the fields. Then identifies priority of each packet. The one that identifies the priority of each packet is somewhat differentiated services, I think. Yes, it's the differentiated services because the service always differentiates its priority of each packet. Then identifies the IP of the sending host. Then that would be the source. I think it's the source. Yes, I think it's the source because of the sending host. Then identifies the upper layer protocol to be used next, and that would be protocol because of the upper layer protocol. It is somewhat a context clues or other things. Then commonly referred to as a hop count. As a hop count is the TTL, I think, the time to live. If the hop count turns to 0, the packet or the frame will be dropped because if you watch the video. Then identifies the IP address of recipient host. That would be the destination IP address because of the address of the recipient host because of that. Then the last one is always set to 0, 100 for IPv4, or as you can see, there are IPv4 Internet Protocol version 4, and that would go to the version. And as you can see, it is perfectly matched and already correct. So let's proceed again to another activity. And hello guys, this is the third activity of the chapter 6. It is, as you can see, it is somewhat the same with the second activity, but I think it has the description is not the same with that, or it is more complex in description. So let's try to answer it. Then is always set to 0, 1, 1, 0. In that, as you can see, it is a binary or somewhat a hexadecimal, so it would be a version. Yes, it would be a version because of that 0, 1, 1, 0. Specify packet congestion control. Congestion control would be in a flow level because of I think it's not in classify packets congestion control. I think it is in traffic class, not in flow label. Let's try in traffic class. Yes, because it's traffic class, it is in control and congestion should be in control. Then suggest that all packets receive the same type of handling by IPv6 routers. And in this statement, to suggest that all packets receive the same type of handling, it is somewhat in, I think, flow label, because of all packets received have same type with, so it should have same label or other specifications. That's why it should be in the flow label. Then when this value reaches 0, the sender is notified that the packet was not delivered. As I've said earlier, the TTL or time to leave is when it reaches 0, the packet or frame will drop. But in this, it is the hop limit. It notifies the sender that the packet is not delivered. Then identifies the application type to the upper layer, that would be the next header. Then identifies the size of the data portion of the packet. And as you can see, that context clues are the size of the data, and that should be the payload length. And we already matched the IPv4 header description to their field correctly and successfully. So let's proceed to another. And we're back to the fourth activity of the chapter 6, to identify the elements of router routing table entry. And as you can see, there are the choices in here: the D1, an IP address, the 192.168.1 support-20/24, the 90/33072 via 9.2.168.31. The I think it's a time to live or a hop time, the 6 minutes and 3 seconds. Then the gigabyte Ethernet 0-0. Then let's try to answer it. The first question is the elapsed time since the network was discovered, and that would be, I think it's the hop time, the E, the 6 minutes and 3 seconds. The administrative distance or source metric to reach the remote location. As you can see, there are two IP address, so let's see if who's the source in here. But as you can see, there is a via word, which means it is the source via 192.168.3.1, so it will be the source. I think it's not. Then no, I think it's not the source. This is not the source. Then this is the one that this is the source, I think. How the network was learned, it would be in, I think it's in A, I think. Then shows the destination. Then show the destination. This is the destination. Then this is the next hop time, I think, and the outgoing. This is my answer for number 2, because I thought it was the 192.168.3, but it's not, because it should be the 90/3072. Then how the network was learned by the router, it is, as you can see, it is somewhat the first thing, the D. So it would port D, I think it's a port D or somewhat like that. Then show the destination network. The destination network would be in B. The 192.168.1.0/24, that IP address would be the destination. Then the next hop time or hop IP address to reach the remote network would be this letter D, the via 192.168.3.1. Then the outgoing would be letter F, the Ethernet gigabyte Ethernet 0/0. Then let's check. Oh, I think it's not. Oh, I misplaced. Sorry for that. I misplaced the letter. Should be in D. The IP, not in E. There's in E. Sorry for that. But the answers are correct. Thank you. Sorry for the miscalculations. And let's proceed to the another. We're back, and this is the fifth activity of the chapter 6, the second to the last activity, I think, of the chapter 6, the network layer. Then let's hurry and try to answer it. Then the description should be connect router to external network, usually over a large distance. As you can see in the choices, the WAN interface, aux port, LAN interface, telnet or SSH, or console port, the only one that has the large distance would be the one, the wide area network interface. So let's connect the wide area network interface in this description. Then a way to remotely access the CLI across a network interface. That would be a telnet or SSH because of the remotely access and the CLI across the network interface. In the, I think it is in chapter 2. Yes, in chapter 2 that idea has been discussed, or information has been discussed. Then computer switches and routers for internal networking, that would be I think it's in a LAN interface because of it is in computers. Then the computers will be connected in switch, then the switch will be connected to another router, and another router can be connected to another switch. It's just like that. That's why it should be in a LAN interface. Then a local port which uses USB or low speed serial connection to manage network devices. That would be the aux port, I think, because, or I think it is the console port. Let's try to analyze it, because if because of the USB consoles, low speed, this has the low speed. Oh yeah, it should be the console port because of this USB and low speed. Then the aux port would be in the telephone lines and modems. Let's check. As you can see, my analyzations are correct, and the fifth activity has been aced again. And let's go to the last activity of the chapter. Guys, I think this is the last activity of the chapter 6, and sorry for my voice because I'm pretty sleepy right now, and as you can see, it is already 10:22 p.m. and I'm still not asleep. Then because of this, then let's try to end this fast, and I'll discuss this. This activity is about the router boot process, and as you can see, it has the step by step, or a process, or in a chronological order. So the first thing you should do is perform post, or a hardware check performed by built-in ROM chip. Then after that the hardware check, or the perform built-in chip in ROM is somewhat, you should load that thing. Copied ROM to RAM, or locates the iOS. Then after that after you locate the iOS, or the operating system file, or for the router, load the iOS. The operating system file for the router loaded into RAM after Bootstrap finds iOS file to be used. Then load the configuration file from Flash or NVRAM, a TFTP server, or go into setup mode to create a configuration file. As you can see, that's a very easy activity, and somewhat, even I already read it only twice. I think I still know what's the process.